Hello everyone, welcome to Brilliant Group of Institutions, Qatar. So we started the discussion of the important questions of a CBSE board examination. We started with the chapter of integration and we finished 2 videos. Now we are going to the third part, that is integration by parts. Integration by parts deals with the integration of the product of 2 functions. And there is a particular rule that we have to follow in choosing which 2 functions should be combined together, on which order it should be combined. And that is what we're going to see in this video, and very important questions from the previous year board examination. Okay, so let's go to the concept now. Integration by parts, we consider 2 functions u and v, and if you're trying to find the integration of the product of u and v, the rule says that integral of uv is given by u into integral of v minus the integral of derivative of u times the integral of v. And in this, the second part, you should be very careful, because in the second part, this whole integration that you see over here is inside the first integral that you see here. We have to complete that operation inside that integral, then only finally do the integral over here. This is the part where many students go wrong. The most important part in the integration by parts formula is the second integration. The first one is pretty easy. We are only integrating the v over here, nothing you're doing with u. Now the problem here is not about by hearting the formula, that is very easy to by heart, but the problem is choosing what is u and what is v. For that, we have a particular order. That order is called I late. I late, very easy to remember. I late. I stands for inverse trigonometric functions, L for logarithmic, A for algebraic, T for trigonometric, and E for exponential functions. This is the order in which you choose which function should be taken as u and which function should be taken as v. For example, I am trying to integrate 2 functions. One is x squared and the other one is a trigonometric function sin x. It is pretty clear that the x squared form that you see over here is the algebraic form, and the sin x that you see over here is the trigonometric form. And in this order of I late, I-L-A-T-E, A comes before T. So we will consider A as your first function u and T as your second function v. Very simple rule. If you know this and the basic integration properties, then it is very easy to integrate this. So the property is very clear, and we use it only to integrate the product of 2 functions, and the 2 functions should belong to one of these categories. And it's not advisable to do parts when both the function belong to the same category. Inverse, inverse, trigonometry, trigonometry, please don't do it. We have other forms to integrate such functions. So ILATE is only used if u and v are 2 different functions of these categories. Okay, so shall we start with the important questions of this topic? Okay, important questions now. So we'll be discussing very easy 2-mark questions and 3-mark questions, as well as difficult 4-mark questions also from this concept. So right away I'm going to the questions now. The first one, okay, the integral of x log 2x. So when you consider the function x log 2x, you can see that the first function is x and the second function is log. Definitely the first one belongs to the category of algebra and the second one belongs to the category of logarithm. So I late, what comes first? In L and A, what comes first? L comes first in I late, right? So we will be considering L as my u and A as my v. Okay, and what is the product of uv? What is the product of uv? U integral of v minus the big integral, the second integral of the derivative of u multiplied with the integral of v. This is the important property of uv. The important property of uv. Let's apply it now. So this is equal to, what is u? U is log 2x is multiplied with the integral of x dx minus the whole integral of the derivative of u, the derivative of log 2x is multiplied with the integral of x dx. And I'm telling you once again, you should be careful with the second part. You should be careful with the second part. Okay, so that is equal to log 2x. And then what is the integral of x? What is the integral of x? It's going to be x power 2 divided by 2. Basic integration result. X power 1. X power n is x power n plus 1 by n plus 1. So x power 1 is x power 2 divided by 2 minus the big integral of what happens inside? What happens inside? The derivative of log. The derivative of a log function is 1 by the function. Okay, but we have learned that when your function is associated with a linear form, you have to take the coefficient of x in the denominator. So this is 1 by 2x, which is multiplied with 2. This 2 is the result of the coefficient of x in the question. This 2 is the result of the coefficient of x in the question. Please be careful. A very common mistake among students in the exam. We know the derivative of log x is 1 by x. But when the function log is associated with a linear form inside it, where there is a coefficient for the x term inside it, that coefficient of x will be divided in the denominator. Okay, multiplied with x squared divided by 2 dx. Okay, so now we can go for simplifying. When you go for simplifying, this x squared will cancel with the x over here. X squared will cancel with the x over here. Then you can see that it's a very easy integration. Now the second part, this is equal to x squared log of 2x divided by 2 minus 2, it's 1 over 8, the integral of x dx. When you simplify, the second integral is now simply x dx. But this is not the case every time. This is a 2-mark question. This is not the case every time. The second integral will get complicated later on. Okay, so that is equal to the final answer. We are going to write the final answer, that is equal to x squared log 2x divided by 2 log 2x divided by 2 minus 1 by 8 into x squared divided by 2 plus c. X squared divided by 2 plus c. Finally, simplified form, x squared log 2x divided by 2 minus x squared by 16 plus c. Since this is the first question, I explained so much in detail. Now we can directly select you, select we. We have to be only concentrating on what happens during the integration. Okay. Now, since we finished this, I have a very important advice to give every one of you for doing a question of integration by parts. Whatever, if you decide that the question is going to be done with integration by parts, I request everyone to call this function that is given in the question as I. A very good advice, because there are certain questions in integration by parts that keeps on repeating. The second integration will not terminate like this question. It keeps on repeating. At that time, during the recurring of the integration, the answer sometimes in between will come back to the question. So I can easily call it as I. So I advise you to keep calling it as I in the beginning. So later you won't be having a confusion when you're doing the question. So I request all of you to keep that in mind. Okay. So this question did not need that. That's why I didn't call it. Now I'm giving you the advice of calling it as I every time you do a question of ILATE. Okay. So let's go for the next question, my dear students. Okay. The next question comes here, the problem. I will be calling this as I. I will be calling this as I. Okay, I will be calling this as I. Now for me, I can see that there are two functions. Yes, the first function is the exponential form e raised to 2x, and the second function is sine of 3x plus 1. Sine of 3x plus 1. So definitely for me, this is the exponential form and this is the trigonometric form according to ILATE. According to ILATE, t comes before e, so my trigonometric form is going to be the u and my exponential form is going to be the v. Keep in mind, ILATE, TE. TE. Okay, so I'm calling this as E, right? Okay, so this is going to be I, therefore I is equal to the integral of e raised to 2x into sine of 3x plus 1 sine of 3x plus 1 dx. E raised to 2x into sine of 3x plus 1 dx. So use the property once again. I'm writing the formula u into integral of v minus the integral of the derivative of u into the integral of v. This is the expression that you have for integration by parts. Applied. That is equal to u is sine of 3x plus 1 multiplied with the integral of e raised to 2x minus the integral of the derivative of sine of 3x plus 1 into the integral of e raised to 2x. This is the expression. This is the expression we have. That is equal to, come on, what is the integral of e raised to 2x? Integral of e is e. But I told you, whenever there is a coefficient for x, you have to divide with that coefficient. So my answer is going to be e raised to 2x into sine of 3x plus 1 divided by the coefficient 2. Keep in mind, where did I get this 2 from? I got the 2 from the, I got the 2 that you see over here from the power over here. Yes, I got the 2 from that coefficient of x. So that is what is the first part. Okay, the second part, all of you. The second part is going to be the integral of the derivative of sine 3x plus 1 is cos 3x plus 1. Derivative of sine 3x plus 1 is cos 3x plus 1. Chain rule, you will be multiplying it with a 3. Okay, and then again integration of that is e raised to 2x divided by 2. Can you see again an isolate form? This is what is happening always with the trigonometry and exponential product. It's a very common question over the years for your CBSE examination. Very common question. So this could be a very good 3-mark question for integration by parts, exponential and trigonometry. Okay, so now what we will do is we will try to identify, this is going to be trigonometry, this is going to be exponential. So trigonometry is going to be considered as u and exponential is going to be considered as v. v. Okay, so that is equal to e raised to 2x into sine of 3x plus 1 divided by 2 minus 3 by 2. Again using the isolate. U into the integral of v. U into the integral of v minus the integral of the derivative of u into the integral of v. Okay, so this is the expression. Yes, the product rule ready. Again, we do the integration again. So keep in mind, this is completely my I. Keep in mind, this is completely my I. So I is equal to e raised to 2x into sine of 3x plus 1 divided by 2 minus 3 by 2. Okay, cos of 3x plus 1, okay, into e raised to 2x divided by 2. Integral of e raised to 2x is e raised to 2x divided by 2. Then minus and minus is plus 3 by 2. Minus and minus is plus 3 by 2. And what is the derivative of cos 3x plus 1? What is the derivative of cos 3x plus 1? This is going to be integral negative sine 3x plus 1 multiplied with 3. Sine 3x plus 1 multiplied with 3 multiplied with e raised to 2x divided by 2. Okay. Now we can easily see something here once again. One more step. E raised to 2x into sine of 3x plus 1 divided by 2 minus 3 by 4 e raised to 2x of cos 3x plus 1 divided by, already we have taken that. taken that, so we don't need that division. So 3 by 4 e raised to 2x, okay? And then you have a minus 9 by 4. If these things are gone, please see what is left inside the integral now. The integral of sine of 3x plus 1 into e raised to 2x. Isn't that my I? So that is going to be minus 9 by 4i. That is what I said. It keeps on recurring again. So again you're going for I late. No need. It's an integral of the product. Again going for I late. You don't need it. Because you got back your I. This is why this question is a very, very important question over the years for your board examination. Product of exponential and trigonometry form. So I can call this as 9 by 4i. So that will come to the left hand side because I am trying to evaluate what is I. I'm trying to evaluate what is I. Therefore, I can say the answer. Therefore, I plus 9 by 4i. I plus 9 by 4i is going to be e raised to 2x. E raised to 2x divided by, so let's keep that as e raised to 2x. Let's keep that as e raised to 2x, and then inside the bracket you have sine 3x plus 1 divided by 2, sine 3x plus 1 divided by 2 minus 3 by 4 cos 3x plus 1. 3 by 4 cos 3x plus 1. E raised to 2x sine 3x plus 1 divided by 2 minus 3 by 4 cos 3x plus 1. Okay, so I plus 9 by 4i is 13 by 4i. So I is equal to 4 e raised to 2x divided by 13 into sine of 3x plus 1 divided by 2 minus 3 by 4 into cos of 3x plus 1. I wouldn't say this can be written as a final answer. If you want, you can take LCM inside that. You can make it as 4 and that will cancel the 4 outside. So I'm not going to write all that simplification part right now. My intention is very clear, to teach you a question which has a product of exponential and trigonometry, which is going to recur again and again and bring back the I. Okay, so very, very important question, and please do the simplification later. I don't have space to do it. That is why I'm keeping the answer there. Okay, one more step I can do where LCM can be taken and 4 can be cancelled out. Please do that. Okay, so I believe everybody understood this question. Yes, so let me go for the next question. Okay, this is also a very good question. It doesn't look like the product. Okay, this doesn't look like the product, but my eyes are very clearly upon sine inverse x and root of 1 minus x squared. My eyes are very clearly upon sine inverse x and root of 1 minus x squared in the denominator. So I know that it's a method of substitution. Why? Because the derivative of sine inverse x is 1 by root of 1 minus x squared. So a function and its derivative are simultaneously existing inside the question. So I can easily go for the method of substitution. Okay. So we should be practicing more questions in method of I will be having a video on that also. Method of substitution, how to identify a question from method of substitution, how to do it. I will be having a video on that also very soon. So that is actually the problem is it's all miscellaneous questions. We can't easily pick out questions which can be used for method of substitution. That comes with only practice, a very, very important and vast topic. Just so focus on questions where you can directly identify, so we can guarantee marks on these kind of questions. Okay, so let's say let t is equal to sine inverse x. Substitution method, t is equal to sine inverse x. So what is going to be derivative of t? That is dt is equal to, derivative is 1 by root of 1 minus x squared into dx. Okay, so dt is equal to 1 by root of 1 minus x squared. So 1 by root of 1 minus x squared dx is going to be dt, and sine inverse x is t, but we have an x also. We have an x also. So from this, all of you, from this we can say that implies sine t is equal to x. What is it? Sine inverse. So sine t is equal to x. So what is going to be the answer? Therefore, my integration question, x into sine inverse x into dx by square root of 1 minus x squared is now going to be, x is going to be sine t, x is going to be sine t, and sine inverse x is going to be t, and dx by root of 1 minus x squared is going to become dt. Now this question clearly looks like isolate. Now the question clearly looks like isolate. For me, this is now an isolate question which says that this is trigonometry and this is algebra. Isolate. L-A-T-E. So A comes first, call it as U, and T comes second, call it as V. Isolate. Okay, so apply the isolate rule. That is equal to U into integral of V minus integral of derivative of U into integral of V. Okay, so this is the expression. Going for the answer, that is equal to T into integral of sine T. Integral of sine T minus cos T. Integral of sine T is minus cos T. Minus the integral of, what is the derivative of T with respect to T? It is no longer X. You have made the method of substitution where X is converted to T. You're differentiating T with respect to T, which is 1. And the integral of sine T is minus cos T dt. Okay, so that is equal to minus T cos T plus integral of cos T dt. What is the integral of cos T? What is the integral of cos T? Sin T, direct integration, right? So minus T cos T plus sin T plus C. We have to make the substitution back. We have to make the substitution back. So substitution says T is sine inverse X. Okay. Now what is cos T? According to me, cos T is root of 1 minus sine square T. Cos T is root of 1 minus sine square T. Why? Because we know the identity. Sine squared A plus cos squared A is 1. Then cos squared A is 1 minus sine squared A. Cos squared A is 1 minus sine squared A. So cos A is root of 1 minus sine squared A. That's going to become root of 1 minus sine T is X. So 1 minus X squared. This is something very, very important. This is something very, very important. Many of you will not be able to substitute. You will write it as cos of sine inverse X. Your answer will be, because you know T is sine inverse X, you say, right, cos of sine inverse X. But that is not the answer they will have in the scheme. In the scheme, they will have root of 1 minus X squared. Keep in mind. So cos T is root of 1 minus sine square T. So root of 1 minus X squared. Plus sine T, again X, plus C. Answer done. Answer done. Okay. So I believe everybody is clear with this question. What is it? X sine inverse X by root of 1 minus X squared. Okay. Next question. Again, a question of X and log X plus 1. This is a very, very important question because we have done a question with X and log, but I'm doing one more because that question was pretty easy in the second part of the integration. The first question that we did in today's video. Yes, in this video, the first question was based on X and log 2x. This is again X and log X plus 1. It is little bit different. That is why I'm doing it. Everybody listen very carefully. What are my functions? X and log of X plus 1. X and log of X plus 1. So this is going to be algebra and this is going to be logarithmic. Logarithm comes before algebra. So U and algebra is V. Okay, so apply this in the product rule. Apply this in the product rule. That is equal to U into, that is log of X plus 1 into integral of V minus the integral of derivative of U. The integral of derivative of U into the integral of V. This is the expression. This is the expression that we have. Okay, that is equal to integral of X is X squared by 2 log of X plus 1, X squared by 2 into log of X plus 1 minus the derivative of minus the derivative of log of x plus 1 is 1 by x plus 1. Yes. The derivative of log x is 1 by x. Log x plus 1 is 1 by x plus 1. There is no coefficient for x, so no need to worry. So that is into x squared divided by 2. This part is where, because in the previous question that we did, it was simply x, so you could cancel x squared and x, but this is x plus 1, you can't do that cancellation. That is why this question is little bit different from the other question. So here we have to be a little bit creative. Okay, it's a board question anyway, so if it comes, you can directly get to the answer. So you have to be a little bit creative. This is x plus 1 and the numerator is x squared. What usually everyone will do is, you will simply divide x squared with x plus 1. The polynomial in the numerator is x squared and the polynomial in the denominator is x plus 1. So whenever you are integrating a rational form p of x by q of x, we learned it in partial fractions video. Please go to video number 2. You can see there partial fractions. In that you will understand how I handle a polynomial form with p of x by q of x. You can simply divide it. You can simply divide it or be a little bit creative like what I'm going to do, which is going to be easier. If you are creative, that is going to be easier. X squared divided by 2 log of x plus 1 and minus this x squared is going to be treated like x squared minus 1 and plus 1. I am creating an x squared minus 1 simply because x squared minus 1 can be written as x plus 1, x minus 1. That will eliminate my x plus 1 in the denominator. I have a 2 there, so I will keep that 2 outside. Keep that 2 outside. Divided by x plus 1 and x plus 1. Okay, I am splitting the numerator as x squared minus 1 plus 1. And why again? Because x squared minus 1 I know is a squared minus b squared, which is a plus b, a minus b form, which will eliminate the x plus 1 in the denominator. That is why I am creating that form. So answer now, that is equal to x squared divided by 2 into log of x plus 1 minus 1 by 2 into the integral of x squared minus 1 is x plus 1 into x minus 1 divided by x plus 1 plus 1 by x plus 1 dx. Okay. I believe everybody understood this. Yes. Those who cannot think of this creativity, you are supposed to remember that in integration of polynomial functions of p of x by q of x in the rational form, if the numerator has a degree which is greater than or equal to the degree of the function in the denominator, then you are supposed to do polynomial division. Polynomial division, something that you learned in 10th standard. Something that you learned in 10th standard. Use that division. You will eventually come to the answer that you're getting now. Okay, you do that division, you will come to this answer, x minus 1 plus 1 by x plus 1. This form you will get, where x minus 1 will be your quotient, 1 is going to be your remainder, and x plus 1 is your divisor. That form you will get. Already taught you this in partial fraction method of partial fractions. Okay, now going for the integration, we are ready for the final answer now. That is equal to x squared into log of x plus 1, x squared into log of x plus 1 divided by 2 minus 1 by 2 into, what is the integral of x minus 1? Integral of x is x squared divided by 2 minus integral of 1 is x. So x squared divided by 2 minus x plus, what is the integral of 1 by x plus 1? It is log of x plus 1. Log of x plus 1 plus c. Log of x plus 1 plus c. Okay, we can write it in a more simpler form now. Okay, start writing. That is equal to x squared divided by 2. Okay, log of x plus 1, then minus x squared divided by 4 minus plus x by 2 plus x by 2 minus log of x plus 1 divided by 2 plus c. Finished. Answer done. This is your final answer for this integration. So I told you what is the importance of this question. That is log of x plus 1 is not easily simplifiable. Okay, the second part when you're trying to do, you have to be either creative or you have to do polynomial division. Okay, So, believe everybody understood this question. Going for the next question. Okay, now this is a very, very important form. Not because this question was asked in the board examination and all, but this form is something just to teach you that integration by parts method is not always done when the integration looks like the product of two functions. Going to see something very interesting over here. Look at this, all of you. See, whenever this is something that I'm supposed to teach you during method of substitution, whenever my students see a square root form, that's always calling for method of substitution. You always call it for method of substitution. That is, whenever you have a square root form, you have to put whatever is inside the square root as t squared. Let t squared is equal to x. Whatever is inside the square root as t squared. So t squared is equal to x. That implies 2t, the derivative 2t into dt. 2t into dt. 2t into dt is equal to dx. That is equal to. So we are going for substitution. Therefore, integral of sine inverse root x dx. Integral of sine inverse root x dx is equal to integral of sine inverse root x is t, because x is t squared. X is t squared. So sine inverse t into dx is 2t dt. Dx is equal to 2t dt. So my intention was very clear. I had to make a substitution for root x. Whenever you have a square root of form, whatever is inside the square root is going to be put as t squared. Keep this hint in mind. Very good 2-mark questions can come from this method of substitution. Put whatever is inside the square root as t squared. Okay, so when you see the expression now, this is going to be 2 into integral of t sine inverse t dt. So again isolate the product. So question was not isolate or the parts question, but now after substitution it became a parts question. Okay, so in parts question we know what is going to be your t is going to be your algebra, and the sine inverse. So for the first time you are getting an inverse form. Okay, everybody clear with this? Inverse form is going to be your u and algebra is going to be v, because I comes the first letter, which should be taken as u, and a comes later on, which will be taken as v. That is equal to 2 times. Start the integration. u into integral of v, okay, minus the integral of derivative of, with respect to t, derivative of u into the integral of v. Okay, fine. Do the answer. That is equal to 2 into sine inverse t into t squared divided by 2 minus integral of derivative of sine inverse t, 1 by root of 1 minus t squared into t squared divided by 2 into dt. T squared divided by 2 dt. Okay, now the second part, again very careful integration. Okay, that is equal to 2 and 2 will cancel. You have that is equal to t squared into sine inverse t squared into sine inverse t minus, before also we saw numerator t squared, denominator is square root of 1 minus t squared. Obviously the numerator has a greater degree. So I did the creative method, right? Create that form. How do you create that form? I need 1 minus t squared. I already have a minus outside. I'm going to utilize that minus and I'm going to write this as minus t squared. Okay, then I will put a 1 over here and I will put a minus 1 over here. Finished. I am creating that 1 minus t squared form, and then I will divide it with the square root of 1 minus t squared that I have. Square root of 1 minus t squared that I have. See that? The same creative method, whenever the degree is going to be something less, greater than or equal to the degree of the denominator, you always try to create that form. Okay, it's advisable because these are going to be very easy 3-mark questions. So it won't be very difficult expression so that only division is going to work. No, you can easily convert it like this. So now these two can be easily simplified. These two can be easily simplified. So answer is going to be t squared into sine inverse t plus the integral of the square root of 1 minus t squared minus the integral of 1 by root of 1 minus t squared. These are direct integration forms. These are direct integration forms in special integrals. Refer to video 1. I won't waste my time. This looks like the square integral of the square root of a squared minus x squared. This looks like the integral of 1 by root of a squared minus x squared. Please go back to video number 1 of integration part 1. You can see special integrals being done there. Okay, please refer to that, get it memorized, and please use it over here. And I'm going to write it directly as the answer. My answer is going to be t squared into sine inverse t squared into sine inverse t plus, what is the integral of root of a squared minus x squared? The root of a squared minus x squared, that is x by 2 root of a squared minus x squared plus a squared by 2 sine inverse x by a squared by 2 sine inverse x by a. That is the answer. Okay, x by 2 root of a squared minus x squared plus a square by 2 sine inverse x by a, and finally minus, what is 1 by root of 1 minus t squared? Sine inverse t plus c, sine inverse t plus c. Now we'll go back for substitution. T squared is x, then t is root x. T squared is x, t is root x. All of you start substituting now. T squared is x, then t is root x. So sine inverse root x plus root x by 2 root of 1 minus x plus 1 by 2 sine inverse root x minus sine inverse root x plus c. Not going for writing the final answer. So integration taught, simplification taught, you just have to leave it like this, or you can go for simplifying. Half sine inverse root x minus sine inverse root x is going to be minus half sine inverse root x. This root x will go inside as you get as 1 x minus x squared inside, and this also can be done with sine inverse root x over here. So simplification can be done. One more step can be done. So let's not waste our time and energy for that. I think you are 12th standard students, you will be able to simplify it further, but this answer is fine. So everybody, I think it's clear. If you have any complications, please go back and just go through the video explanation again. I think it is very easy to understand this. Okay, so my intention is not to teach you this question. My intention was to teach the next question from your NCERT book. Okay, it's a very, very good question for 4 marks. Very good question for 4 marks, all of you. But the interesting thing is, when you see this question, nobody is going to expect that this question is going to be done with integration by parts. You will all believe, okay, this is something else. Oh, very complicated. No, this is going to be done with integration by parts. And my eyes directly goes on this expression in the denominator. My eyes directly goes to this expression on the denominator. Okay, this is something that you have learned in chapter 2 of term 1. Sine inverse A plus cos inverse A. Sine inverse A plus cos inverse A. All of you try to recollect it. Sine inverse A plus cos inverse A always is pi by 2. It's a property of inverse trigonometry function in term 2, term 1, but it was not discussed much because the properties of inverse trigonometry was deleted. But it's one of the most important property every teacher is expected to teach their students. Sine inverse A plus cos inverse A is pi by 2. So the denominator is pi by 2. Instead of A, it is root x. Instead of a, it is root x. Okay, then what is cos inverse a? Cos inverse a is pi by 2 minus sine inverse a. Cos inverse a is pi by 2 minus sine inverse a. Now let's go for the question. Therefore, I'll just consider the expression, my dear students. Sine inverse x minus cos inverse, not x, it is square root of x. Cos inverse root x divided by sine inverse root x plus cos inverse root x. Okay, this is my expression. So what is going to be the numerator? Sine inverse root x minus cos inverse root x is going to be pi by 2 minus sine inverse root x. Pi by 2 minus sine inverse root x whole divided by pi by 2. This is the expression we have. See, that complicated form they gave in the integration is no longer complicated. It is easier now. Yes, so this expression is now going to be 2 divided by pi, okay, and sine inverse root x plus sine inverse root x is 2 sine inverse root x, 2 sine inverse root x minus pi by 2, okay, 2 sine inverse. Now I will go for integration. Now, in the integration of this, what is going to happen? We already know how to integrate sine inverse root x, right? So, that is equal to 2 by pi. So, integral of, that implies the integral of sine inverse root x minus cos inverse root x divided by sine inverse root x plus cos inverse root x is equal to 2 by pi, the integral of 2 sine inverse root x minus pi by 2. Now we know how to integrate sine inverse root x, right? Yes, so answer is going to be 4 by pi, just one more step, sine inverse root x minus 2 by pi into pi by 2 is 1 dx. This is the expression. 2 by pi multiplied to pi by 2 is 1, reciprocal of each other. Okay, so what is the expression for integral of sine inverse root x? X sine inverse root x plus root x by 2 root of 1 minus x and 1 by 2 sine inverse root x minus sine inverse root x plus c. So that I will simplify it now. Okay, that is equal to 4 by pi into 4 by pi into x sine inverse root x, just a minute, x sine inverse root x plus root x by 2 root of 1 minus x, okay, plus root x by 2 root of 1 minus x plus half sine inverse root x minus sine inverse root x plus c. Okay, don't forget something here. We forgot about this part. Yes, what is the integral of 1? It's going to be minus x and then we have a plus c. So you're going to combine these sine inverse x root x forms, and this is going to be entire thing inside the bracket over here with 4 by pi. 4 by pi and x is separate, okay? That is equal to 4 by pi, okay? X into sine inverse root x, and that is going to be minus half sine inverse root x plus root of x minus x squared. This is root x, this is root of 1 minus x, so x can be multiplied inside. X minus x squared divided by 2 minus x plus c. Okay, so this is going to be what? You can see that sine inverse root x is common. You can see that sine inverse root x is common. So you can write this as x minus half, which is 2x minus 1 divided by 2 sine inverse of root x plus root of x minus x squared divided by 2 minus x plus c, and the 2 will cancel with the 4 outside and make it 2. So the final answer is 2 by pi into 2x minus 1 into sine inverse of root x plus root of x minus x squared minus x plus c. Minus x plus c. This is your final answer. So everybody, this question is a very good question for 4 marks, and this was easier because we already knew the integration of sine inverse root x. I utilized it from the previous question. That is why I taught that separately. If I taught this question inside this question, you will never understand this. That is why I taught that separately, and I'm utilizing that sine inverse root x inside this. Okay, everybody clear with this question? Yes. So please go through this question once again, everybody. It's not that easy to digest it, but I want everybody to go through it once again to get it clear. Okay, just one more question in this category. One more question. Please look at this question, all of you. What is the question over here? Root of x squared plus 1 log of x squared plus 1 minus 2 log x by x power 4. Again, it looks very complicated, not in the isolate form, but this is again isolate. And the importance of this is, it is a very, very creative substitution that I'm going to do here. So let's take the simplification first. My simplification is, I have the square root of x squared plus 1, and inside that I have log of x squared plus 1 minus 2 log x, okay, divided by x power 4. Divided by x power 4. So what we are going to do is, we are going to take x squared common out. We are going to take x squared common out from this term, from these two terms which has x squared plus 1. We are going to take x squared common out. So when you take x squared common out, from the square root it becomes x, and this is going to become 1 plus 1 by x squared. Okay, and this is going to be x squared again out. So it's going to be log of x squared into 1 plus 1 by x squared minus, according to the property of log, this 2 will go in the power. It is going to become log x squared divided by x power 4. Okay, that is going to be x power 4 is going to make it 3. X and x power 4 is going to make it x cube. Now again we have a property of log multiplication, log AB. Log AB is log A plus log B. Log AB is log A plus log B. So this expression is now going to be root of 1 plus 1 by x squared into log x squared plus log 1 plus 1 by x squared minus log x squared divided by x cube. Now you cancel log x squared positive, log x squared negative. Cancelled off. Now the expression is reducing. I believe everybody is understanding. The expression is now reducing. So the reduced expression is going to be what? The reduced expression is going to be root of 1 plus 1 by x squared into log of 1 plus 1 by x squared divided by x cube. I now think some of you, at least some of you, would have understood my intention. See, now the expression that I got is having something very similar. See this? Do you see this? 1 plus 1 by x squared. I'm going to put that as t in my integration. So I is equal to the integral of this, and I'm going for the substitution. Let t is equal to 1 plus 1 by x squared. T is equal to 1 plus 1 by x squared. Then what is the derivative? What is the derivative, all of you? The derivative says dt is equal to minus 2 divided by x cube. dt is equal to minus 2 divided by x cube. Okay, let's write dx over here. We should have written dx here. Okay, fine. So dt is equal to minus 2 by x cube. So minus half dt is equal to 1 by x cube dx. Minus half dt is equal to 1 by x cube dx. Okay, this is the integration we have. Okay, now let's go for the substitution now. Let's go for the substitution. My integration, therefore, what is my I? What is my I? The integral of root of 1 plus 1 by x squared, root of t log t into minus 1 by 2 dt. Minus 1 by 2 dt. Now isolate. Algebra, yes, logarithm. Algebra, logarithm. Logarithm is obviously my u, the first function, and algebra is going to be my v, the second function. Okay, integrated now, all of you. That is equal to u into integral of v minus the integral of, we forgot about the minus half, put the minus half in front of it, okay, and integral of derivative of u into the integral of v. That is equal to minus half log t integral of root t t raised to 3 by 2 divided by 3 by 2 minus the derivative of log t 1 by t into t raised to 3 by 2 divided by 3 by 2. Okay, that is equal to minus half log t into t 2 by 3 t raised to 3 by 2 minus this t is power of minus 1, so it's going to become integral of 2 by 3 t raised to 1 by 2. T raised to 1 by 2. Okay. Further, next step, that is equal to minus half log t into 2 by 3 t raised to 3 by 2 minus 2 by 3. T raised to 1 by 2 is again 2 raised to 3 by 2 divided by 3 by 2. And this is going to be cancelling. This is going to be cancelling here. Okay. This 2 by 3. Oh no, sorry. It doesn't cancel like that. My mistake. It doesn't cancel. So it's going to be simply 2 by 3 over here. Plus c. So answer minus half log t into 2 by 3 t raised to 3 by 2 minus 4 by 9 t raised to 3 by 2 plus c. Substitute t is equal to x1 plus 1 by x squared. T is equal to 1 plus 1 by x squared. Substitute back all of you. That is equal to minus 1 by 2 log of 1 plus 1 by x squared. Log of 1 plus 1 by x squared, okay, into 2 by 3 1 plus 1 by x squared raised to 3 by 2 minus 4 by 9 1 plus 1 by x squared raised to 3 by 2 plus c. I think this is the answer. Okay, so everybody, please go through this answer. You will be very clear with it. These are some important questions which might come from IELTS and some questions which does not look like an IELTS question and we convert it to IELTS. So I believe everybody is very clear with this explanation for integration by parts. There are a lot of questions in integration by parts. I tried to do some important forms which I believe might come for your CBSE board examination. So all the best, and we're going to be going for the next video very soon. Okay, so please wait for the next video. Thank you and have a very nice day, dear students.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.